Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 1449, let's localize the landing. So now I'm in the cockpit of the pre-takeoff preparation of the Boeing 787-900 jet aircraft. I'm going to start showing you the cockpit influences, displays, and the functions of the Boeing 787-900. The aircraft, I'm going to start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot, flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute, all the steepness of the trigonometric angles in degrees, can climb descent. Also the flight path angle, we can select from the autopilot flight director system panel. We have also the autopilot flight director system panel, the target airspeed selected over there. Also in the primary flight display you can see the altitude indicator with the artificial horizon, the pitch ladder decrease, the bank angle decrease, the ILS localizer. We have the ILS localizer of the onboard antennas of the aircraft that receives the radio frequencies transmitted from the terrestrial runways, antennas that transmit the radio frequencies, so we can align with the horizontal magnetic north pole heading of the runway we're going to use for takeoff and for landing. So we have the runway 14 in Zurich International Airport, Lszh in Switzerland. So we can align with the magnetic north pole heading of 136 degrees both for takeoff and for landing. ILS localizer, instrument landing system. Also the vertical, we can follow the vertical flight path, the vertical glide slope for approach and landing. We have also the ILS localizer, crossbus, the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the autothrottle. Later on, vertical navigation modes. We have also the HSI, the horizontal situation indicator with the magnetic heading and track that displays also the integrated display of the flight plan. We have created a flight plan or a flight path or a route using the flight management computer. We input all the data of the aircraft for this flight. So you can see the stars, the waypoints over here. So I'm gonna show you in a couple of minutes how I'm gonna create. We're gonna select the waypoints that will be connected with the purple line, and the aircraft can follow automatically if we need, using the autopilot flight director system panel in the vertical and horizontal guidance of the aircraft, or we can fly manually the flight plan of the aircraft as it is displayed in the navigation display, both in horizontal and vertical. Over here profile, as you can see we have the horizontal profile and the vertical profile. You can see also the aircraft, how far above the terrain is gonna be flying over here. We're gonna be flying hundreds or thousands of feet above the ground. You can see also the ground, the terrain below and around you. So I'm gonna show you, we have the navigation display over here. So the navigation display that displays the GPS position, the magnetic north pole, and the geographic north pole and magnetic variation depending on where we are in the world. We have the terrain map with the airports where they are located. In the terrain map you can see also the terrain elevation around you displayed with red, green and yellow indication depending how far away the terrain is, and the altitude difference between the aircraft and the terrain around you or in front of you. So you can see the red, green and yellow indications of the terrain. You can see with blue the lakes, the rivers and the sea. We have also the airports are displayed. So we have our own airport with the runway we can use for takeoff and for landing. You can use, you can see the runway length and the taxiways and other information, other data. We have the runway heading, the runway length, the other runways, and the taxiways from the GPS. We have also the other airports. Right now we have the range over here, like you can see the range of the navigation display. The magnetic north pole here, 333. The range is 18 nautical miles, the ground speed of the aircraft. So this is the map display. You can see the airports, how far away they are, the wind direction and speed, other information. They're displayed with 4-letter name. so you can change the range, you can see further or closer to you. So we have all this information. We have also other aircraft that fly around our own aircraft are displayed using the transponder, the ADSP and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. It will display, I will make calculations from the radio frequency difference timing, so we can calculate the other aircraft where they are located, the altitude difference in hundreds of thousands of feet from our aircraft if they are higher or below our aircraft. Also whether they climb or descend with respect to our aircraft. We can also calculate velocity closer in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system, so you will see the other aircraft displayed with a diamond shape, and the warning it will need in that run or in that flight conditions. So we have also so this is the general information from the navigation display. We have also the flight plan, also is going to be displayed as I told you using the waypoints. So we have the navigation aids displayed in the navigation display. We have the VOR ADFs and DBs, the VOR stations and the ADFs and DBs. Also the waypoints which are horizontal and vertical navigation fixes the aircraft can fly through. So we're going to select some waypoints that are going to be displayed in the navigation display. Also it's going to be connected, they're going to be connected from the flight management computer in the flight plan. We will create the flight plan in the flight plan page. So we'll start showing also the other information and stuff from the aircraft. I will show you like things like the flight controls. So you can see we have the side stick here that control the elevator of the aircraft for climb descent. As you can see, this is the Airbus identical size, so you can make turns left and right like this. You can use the control wheel in the Boeing aircraft to make left and right turns using the ailerons and the spoilers. This is the pitch axis, the elevator, for making only climb or descent. Also you have the rudder pedals over here. So I use this axis for the rudder pedals, the going on vertical axis to control the rudder, or you can see the outside. So we can use this to climb a descent over here using the elevator for climb descent, using the rudder pedals and also ailerons and spoilers like this. This is left and right turn. So this is the roll axis. I will talk to you about the flight, about the aerodynamics of the aircraft, how you use the flight controls over here. So we have the movement. You can see the side stick deflection is proportional to the yoke deflection. The thrust levers also function over here. Use this slider to control all the thrust levers over here. So move forward or aft. I can select how much percent of thrust available I need using the thrust levers over here. You can see the engines will not configure for takeoff right now. It takes like a couple of seconds for the engines to react. So when we move the thrust levers forward, we give command to the FAREX over here. The FAREX are the full authority. These are electronic control computers, one per engine and one installed per engine gearbox, dual tunnel redundancy. If one tunnel fails, the other takes over, controls, monitors and displays all the engine data you see from the engines, like the N1, which is the low speed starters have low pressure compressor into one of the turbofan with the engine, the exhaust gas temperature per engine. The N2, which is the high speed starters have high pressure compressor into one of the turbofan with the engine, the fuel flow per engine per 1000 kilograms, 1000 pounds, all the pressure, all temperature, all quantity, and the vibration of the N2 states of the engine. So you can see here is the N1, which is the low speed starters have low pressure compressor into one of the turbofan, which is edging the left and the right in idle position like this. Here is the idle, as you can see. So we have also the exhaust gas temperature in Celsius degrees. The N2, which is the high speed starters have high pressure compressor into one of the turbofan, which is engine the left and right. fuel flow parameters per 1,000 kilograms, thousands of pounds, oil pressure, oil temperature, oil quantity, and vibration of the two stages of the engine. We have also the cabin pressurization from the outflow valves of the fifth and ninth stage of the engine supply both cabin pressurization system. You can see cabin altitude, rate of climb, descent over here. So we have cabin altitude 8,000 feet when we fly at 45,000 feet, and the differential pressure will be 8 psi approximately. Line at altitude, outflow valves over here. So we have also gross weight for takeoff 544,000, and the total fuel on board right now. So maybe we need to change the fuel. I need to change. So maybe you can change it from the flight management computer. I have to change it. From over here, from this display. So we're gonna set over here. I'm gonna show you all the data we need. So we have full fuel on board, 231,000 pounds. The minimum fuel temperature right now. So we're gonna see how the aircraft will behave with full fuel on board. How we can change it later. We're gonna use 30% for the left and the right wing, and 10% we're gonna decrease the fuel on board. 10% for the center tank. So we're gonna make calculations using the flight management computer over here. Gonna be calculated automatically. So I will show you also the primary flight display right now and the other functions. You can see here. So we have the primary flight display over here. Very important, the airspeed tape. You can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the barometric altitude. So this airspeed and altitude, altitude above the ground, altitude above the sea, barometric altitude, the vertical rate of climb descent of the aircraft in tens, hundreds, thousand feet per minute. You can see how fast the aircraft, the rate of climb or rate of descent, vertical speed indicator. So this needle moves up when you climb after takeoff, or moves down when you descend. You might have a positive attitude, pitch attitude over here. So this is the pitch ladder, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down over here. Also the bank roll over here when you make turns. Over here you can see other information, the target altitude, target airspeed, and the heading in the HSI, the target heading. So we have also the ADF left and right over here, the GPS display, the position of the aircraft. So you can see the airspeed, the altitude, and the heading over here are the same values as selected from the autopilot flight director system panel all time. The airspeed 200 knots or nautical miles per hour. Or we can select Mach in higher altitude. We have indicated heading over here 360 degrees, vertical rate of climb descent and now is 0, not selected, and the altitude selected is 10,000. So we have here also autopilot engage and disengage switch. You're gonna see later. The LNAV with the VNAV, lateral navigation, vertical navigation, flight level change, climb continuous, auto for flight director over here. Systems display, you're gonna see the displays over here. I'm gonna select the systems of the aircraft, the checklist, communication. We have also, as I told you, here in the primary flight display, the airspeed, which is very important, and the altitude and the vertical rate of climb descent of the data of the aircraft. You can see barometric pressure for the barometric altitude, 29.92 inches of mercury over here. Selected from here, from this panel, from the FIS panel, electronic flight instrument, baro set over here, as you can see, inches of mercury, hectopascals. Minimus radio baro, the plan and the range of the aircraft on the display over here. You can change the range, the plan, what it displays, the mode. We can select weather radar on the display. Traffic, we have the terrain right now selected to display over here. You can also select from this screen here, from the touch screen or the mouse pad here. So I will show you a few more things we need to know. So you can see also the head-up display, also the same things like in the primary flight display. All information, takeoff, go around, the flight mode done on 0 with the autopilot auto throttle. So now it's on the auto throttle arm for the takeoff, go around, left and right. So also in this display you can see the flaps position, also displayed how many flaps, how many degrees, 30 degrees fully extended, the stabilizer, horizontal tail trim and the rudder trim position. So we're gonna make a few more selections here. I'm gonna show you a few more systems before we're going into flight. So you can see here also the outside view. I will show you how to use the flight controls of the aircraft. So we have here, before showing you the flight controls of the aircraft correctly, I'm gonna show you the horizontal trim, stabilizer, the flaps and the speed brakes function. Then I'm gonna show you the flight management computer, how to create a flight plan. So stay with me until the end part of the video. I'll show you all the systems of the aircraft, and we're gonna make a complete flight from takeoff, climb, cruise, descent, approach and landing in the end part of this video. So you will see the complete flight, full manual. Also the overhead panel over here, all the systems, what we need to do before for starting the engines, the cabin pressurization, for instance, the hydraulics, the electric system over here, the flight control computers. Over here you can see the primary flight control computers in the auto position. So this is a fly-by-wire aircraft, like the Airbus aircraft. It has the flight control computers. Fly-by-wire aircraft. It has the normal, the alternate and the direct mode of the flight control channels. So you will see how we're gonna use it for flying this aircraft. We're gonna use also for horizontal trim, stabilizer, autopilot, flight director system panel, and other things we need to do. So the fly-by-wire system, I'll start explaining. We have also the air data computer over here. You can see heading reference alignment, inertial reference alignment. We can do it flight control computers, flight control services. So the flight control, the air data computer display the airspeed, the pitot dynamic and the pitot static for the barometric altitude and the vertical rate of climb descent, with the difference of the air pressures calculated, the angle of attack of the aircraft as it flies, the pitch attitude, the GPS position, the magnetic north pole, the graphic north pole. So this is all the air data. Also the laser gyroscopes, gyroscopic acceleration, deceleration of the artificial horizon. This is calculated with laser gyroscopes. So this is the air data computer that is doing all these things. Also inertial alignment, you will see later the GPS position. All this is done from the air data computer. Airspeed, altitude. So you can set the inertial reference position over here later if you need. So I will show you now the flight control computers, also the trimming of the horizontal tail of the aircraft. As we fly, we have this trim switch, so we can use it to trim the horizontal tail up and down for pitching up or pitching down the nose of the aircraft as we fly. So we have this trim switch over here, the horizontal trim stabilizer, as you can see. So you can see it's in the control wheel, so you can use it with our hand all the time. So you can see what it reads. It says elevator trim elevator trim, left click down, right click up. As you can see over here, elevator trim. So this is the elevator, the horizontal elevator of the aircraft. So this way you trim up the elevator and you pitch up the nose of the aircraft as you fly, pitching up, and this way you trim down the elevator and you pitch down the aircraft nose as you fly. So it's very important to trim the aircraft, the jet aircraft, as you fly. So one more time, you can see we trim the horizontal elevator up and down like this, or in some other aircraft you trim the horizontal stabilizer, the whole surface of the horizontal stabilizer, like in the Airbus. So you can see also an aircraft now is coming for landing. So we have also we have these suites. So this is the normal channel of the flight control computers, the manual trim suites. We have also the alternate trim suites of the manual suites trimming over here. This way you trim the nose of the aircraft up, the elevator up, and this way you trim the nose of the aircraft down, trim the nose down, trim the elevator down, and you pitch the nose down. So you do it as you wish, as you find more comfortable. You have also the parking brakes here with this switch. You have also this stabilizer trim cutoff switch. So this is for all Boeing 737, Boeing 747, Boeing 57, 737, 747, 757, 767, 777 and 787. You open up from normal to cutoff. You have a failure and you can disconnect either the left or the right stabilizer trim or elevator trim, whatever you have. Some aircraft have a whole stabilizer. So you disconnect if you have a failure of over here of the hydraulic system that affects the auto trim function of the autopilot flight director system panel, because as I told you, this is a fly-by-wire aircraft. As you can see, it has the flight control computers. You can trim the horizontal tail automatically, as you can see. So if you have such a failure, you can come over here and disconnect from normal to cut off this switch, the stabilizer trim cutoff switch, and then you use you lose the automatic trim. You can see L2 stabilizer cutoff switch into an R2. So you use only the alternate or the manual trim switch over here. As you can see, you can trim using the switch all the time, trim up or trim down the other way, or the one you have over here in the control wing, all the time manual trim of the elevator. You can see also the flap speeds over here as displayed. So you trim, very important, the horizontal tail trim up or trim down as you fly, and you pitch up or pitch down the aircraft. You have also the autopilot disconnect over here, the switch and the head-up display declutter. As you can see, it reads head hood declutter switch. So this is I'm gonna show you the flight controls a little bit more detail now. So you need the horizontal trim stabilizer. I have it here, this switch. So this is what it's doing. As we fly, we can climb for and descend using the elevator for climb and descend, and we can trim it the same way, the elevator to move up or move down, or the stabilizer, so it will balance the aircraft in flight, control the aerodynamic forces. So I will talk to you now about the aerodynamics of the aircraft, about the Newton's physics and after aerospace engineering, and show you and derive some principles and equations we need to know for the air transport pilot license and the commercial pilot license for flying the jet aircraft. So we have a beautiful jet aircraft tonight. I'll show you how to use it. I'm gonna show you. So we have the outside view of the aircraft. You can see the wings, the forward wings of the aircraft hold the aircraft weight as we fly. So we have also the vectors, the thrust from the engine, the jet propulsion, the jet plus over here, as you can see, which pushes the aircraft forward from the jet stream, from the cones, the exhaust of the engine. So we have also the compressor of the engine, the turbine, the front fans sections. You have also here in the wings where the lift is produced. You have the mineral dynamic chord position, which is 23% of the mineral dynamic chord, where the maximum dynamic lift occurs in the forward wings. Also where the stall will begin, the airflow becomes detached from the top surface of the wings as we fly. So we need to pay attention over here this screen to know if the aircraft is gonna stall. You have to pay attention to the airspeed tape over here, so you will see with red and yellow the indication of the stall. So we need to have a thrust available and pitch down the aircraft if we are near stall condition. So we can see also we have the center of pressure is moving forward enough, the mineral dynamic chord, the center of gravity over here is where the yawing axis, where the rudder pedals control the aircraft for left and right turns using the rudder, the vertical stabilizer of the airplane, of the aircraft. So you can make left or right turns, and also you can use the nose wheel of the aircraft in the ground. So you can see you have a nose wheel for nose wheel steering for making left and right turns. In the ground you use the tiller also. So you saw the tiller over here. You can see in the ground is interconnected with the rudder pedals to control the nose wheel for making left and right turns. You control the nose wheel left and right like 76 degrees, either left and right direction, from 0 to 45 knots. Then it decreases to 7 degrees deflection up to 80 knots in takeoff. Then it disconnects and you have only the rudder. So the rudder is aerodynamically effective from 45 knots, and this is the yawing axis of the aircraft. So you can see the yawing, the rudder pedals over here. The yawing axis. Also you have the toe brakes in the top surface. So we have also another axis from wingtip to wingtip. We have the pitch axis. We can control the elevator for climb and descent. The pitch axis of the aircraft. So this is the elevator control. Also the elevator trim, as you can see. So we can climb and we can descend. We use all the controls together, and we have one more control. So you can see the elevator is like this: climb, descent, elevator control. You can see the side deflections proportional to the yoke deflection. Both sides also move together. So we have also the longitudinal axis from nose to tail, which is the roll axis. You can make turns either to the left and the right side using the ailerons and the spoilers. And you use in the Airbus, you have the elevator, the pitch axis moving up and down the side stick like this. In the Airbus aircraft, in the Boeing you move the yoke, and also in the Boeing you move the control wheel. In the Airbus you move the side stick like this, left and right. So they both do the same work. So you have the control wheel to control the longitudinal axis of the airplane as it flies to make left and right turns. So you have all flight controls together. If you need like this fast deflection proportional to yoke, you can see the captain and the first officer move together in the Boeing aircraft. They're interconnected, all flight controls, not like in the Airbus you have the side stick priority. Also this is fly-by-wire aircraft, I will explain you. So you can see also the wings. You can see the bottom surface of the wings is more flat using the burning material fluids and Newton's physics. You can see as we fly for takeoff, the airflow is moving slower below the wings, so we have higher pressure. Also the flaps are extended and we take an angle of attack like this for takeoff. So we have we have higher pressure below the wings, which pressurizes the aircraft with the wings up into the air. Also, the top surface of the wings, using again the atmospheric fluid, you can see is more curved, so the airflow is moving much faster above the wings, which sucks the aircraft away and wings up into the air. It creates lower pressure. So we have differential pressure between the bottom and the top surface of the wings. The aerodynamic lift is produced, and we can fly when we have an airspeed about 250 kilometers or higher in takeoff, or 140 knots. So you will see a couple more things for the flight controls. Also, I will show you one more view of the flight controls, then I will show you the rest of the systems of the aircraft. um, so I'm gonna show you this view. I'm gonna show you how to use, also I forgot to mention, the thrust levers, the speed brakes, and the flaps of the aircraft, which are secondary flight controls, the flaps, slats, and the speed brakes. So I'm gonna show you this view, then we go for the rest of the systems. So you can see again the side stick here. Hope you like it. So you can see we can move the side stick like this. So we climb and we descend again. As you can see, it's the same side stick like in the Airbus aircrafts. So we climb, you control the Boeing jet aircraft also. So we climb and we descend, identical function. Make turns to the right, make turns to the left. I hope you can see in the screen what is reproduced over here. So we have full flight control, side stick deflection, propulsion of the yoke, deflection, horizontal trim stabilizers, thrust levers. Over here, these switch controls over here, the thrust of the engines. We move forward or aft. Again, the thrust levers. So this is all flight controls. So we need to have also the outside view, as you can see. So again, we can climb, we can descend, make turns left and right, ailerons, spoilers and flaperons, left and right turns, like in the Airbus. So this is all flight controls we need to know for now. I'll show you the rest of the systems. Make the engine start demonstration. So we'll go for the flight management computer over here. I will show you how to input the data of the aircraft for this flight. So we're gonna use the takeoff gross weight, the empty weight plus the passenger plus the cargo plus the fuel on board, how much fuel we have stored right now. We can use like 30% the left and the right wing and 10% in the center, or now we have 100% in every tank, in the left and the right and the center tank, left wing, right wing, and center tank. So we have takeoff gross weight calculated, the center of gravity, also the mean aerodynamic chord position for takeoff, and the horizontal trim stabilizer for takeoff and for flying is calculated automatically, since this is fly-by-wire aircraft. We can use the flight management computer to make calculations about the center of gravity as we fly, easily calculated. So the center of gravity of the aircraft is calculated from the flight management computer automatically. Also, as we fly, we burn fuel, so the center of gravity is shifted, is recalculated automatically. Also, the flight control computers control the deflection of the flight control surfaces that I show you. We have also the hydraulic fluid over here. which is pressurized from the engine and electric pumps, and also from pressurizer air. It receives pressurized air from the engines, 5th and 9th stage, to pressurize the hydraulic fluid. Tanks for the flight controls, landing gear, external track, flaps and slats, speed brakes, thrust reversers, parking brakes, normal braking, and other things. So we have also outflow air from the engines using the FAREX. I will talk to you later. For cabin pressurization, we can engine anti-ice, air conditioning, ventilation, oxygen regulation in the cockpit. So we have the flight management computer. I will use it to input all the data of the aircraft for this flight. As I told you, the takeoff gross weight, the flaps for takeoff, the aerodynamic chord position, the horizontal trim stabilizer 4.25 degrees, aerodynamic chord 23%, and the takeoff speeds are going to be calculated. The V1, V2, and V2 for this runway length. We have the Zurich International Airport, Lszh in Switzerland, the runway length, the runway slope, the wind direction, speed, the barometric pressure, the temperature of the air, and also the runway conditions. If it is size dry or wet, it's gonna give us the takeoff speed. V1, V-rotate, we're gonna have 130 knots, and we take off approximately 140 plus 15 knots maybe. Then we're gonna have also the seats, the cyber instrument departure waypoints and fixes that include horizontal and vertical navigation fixes. Also, I forgot to mention, we're gonna have a pitch average of 9 degrees in takeoff rotation, and full takeoff thrust power. We're gonna have the seats. We're gonna climb to the cruise level, like 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints, then we're gonna initiate the descent back to the airport. We're gonna descend back to 7 or 6,000 feet above the sea level for the terminal approach and landing. We're gonna have the SARS, the Southern Terminal Arrival waypoints and fixes for the terminal approach and landing of the aircraft, which are in horizontal and vertical navigation fixes and altitude and airspeed constraints. So we're gonna be aligned also with the ILS localizer with the instrument lighting system that transmits radio frequency from the threshold runways antennas are received from the onboard antennas of the aircraft. We can align us with the runway heading, the magnetic north pole heading of 136 degrees. Also the vertical glide slope for approach and landing. We're gonna be having 25 to 30 degrees of flaps extended, 160, 170 knots of airspeed or 270 or 300 kilometers an hour. I'm gonna approach and land with the landing gear extended. So you're gonna see also the flight management computer I'm gonna use for creating the flight plan. You can see we have the mouse pad here to input all the data of the aircraft for this flight. So I'm gonna use the flight management computer, the mouse pad that I have here for controlling the mouse pad of the aircraft, and the screen that displays the flight management computer. I can use also my keyboards here, as you can see. So I have the control of the data of the aircraft here using this mouse pad screen. So you input here the data. As you can see, you can select identity, position, performance, takeoff, approach, financial status, navigation data, flight plan, load air traffic control rates, load for safe flight plan. So we can select also from the screens here other data. So I'll show you very quickly now how to create the flight plan. I'm gonna come here, control quadrant, as you can see. So this is a nicer display of the aircraft over here. So you can see we have the mouse pad again, the flight management computer, the keyboard for numeric. So we have the identity, Boeing 787-900 GNX engines, the air position, Lszh airport over here in Switzerland, the takeoff, also the GPS alignment. So we have the index again, performance. We're gonna use 0 fuel weight plus fuel on board, gross weight for takeoff. Then we're gonna have the other data like the cruise altitude and the reserve fuel. So we use Lszh, this airport, for departure over here, back to Lszh. over here, clear the discontinuity. Runway 14 over here for takeoff and for landing. So we have reserved the route departure arrival over here. So we use the runway 10, 14, 16, 2832. We can select either runway, so we select runway 14 and the seats that are arranged for the departures, the Zui to Alpha. So we use departure arrivals again over here, so we select the arrivals. So we can select VOM 16, 2834, ILS 14, ILS 16. Over here, ILS 28, ILS 34, GLS 14 localizer, 28 localizer, 34, and this is the stars as our terminal arrival waypoints and fixed. So select ILS 14 Transamity, and the stars select the Negria 1 Alpha. So this is how to create the flight plan. You can see the route is active, not activated yet, it's blue. We need to activate. So we have the first waypoint, second, third, fourth. This is the complete flight plan. Climb to the Zui, Negria Amity. The distance from one waypoint to the other, also the altitude we're gonna be flying. So we have the reserve fuel 5%, cruising altitude 35,300 feet over here. Cost index 100%. Fuel freezing temperature minus 37 degrees over here. And cruising center of gravity 28%. So we have the request of the flight plan we can execute over here. So it will give us the first waypoint, second one, the airspeed, also altitude, the Zui 6 nautical miles, 250 knots, 6000 alpha. Then climb, we make a turn. This is the runway heading, a few nautical miles, 1, 3, 5, 6. Then we make a turn 071 degrees, 26 nautical miles from Zurich, 320 knots. This altitude is Negria. Then we descend this flight level. No, we keep climbing. Amity, Zui. Then we descend ZH 701. Approach and landing TRA. Runway 14. One waypoint by another. Also, we can use the takeoff. Flaps, center of gravity, trim 22%, 6.75 degrees, and we have higher airspeed for takeoff because we have higher weight. So we go back to the virtual cockpit. We have a couple more things to see. We can set the takeoff weight as I told you. So you can see here the screens we can set for displaying the flight plan over here. The complete route, also this screen here. So you can see also the terrain in front of you, the GPS position, the terrain, the runway we're gonna use for takeoff, the taxiway over here in front of us. This is the airport we are located. The aircraft symbols, you can see the taxiway. This is the one we have in front, the other runway, and the terrain in front of us, how far away we look, just like in the outside view, as you can see. So we can set again a little bit further away. We're gonna see the other plan also, this view. So this is all the navigation displays, the aircraft again, symbol, map centering, the elevation of the terrain. So this is all we need to know right now. The flight plan has created other airports further away from us. So you can see here is Germany, France and Switzerland. Also the vertical flight we're gonna have over here, how we're gonna climb and cruise through. So we will have not much time to explain everything. In this flight we're gonna set only autopilot flight direction system panel over here. So you can see the airspeed we can set for takeoff. We have the takeoff speed 253, LNAV and VNAV, auto throttle left and right over here, as you can see. Autopilot engage, disengage, flight director over here. So we have the heading and the altitude only to fix, the bank angle of the aircraft, vertical rate of climb descent. set the heading and the altitude here, like as much as you wish. I'm gonna set it 35,000 and 300 feet. Also the vertical rate of climb descent. So this is how the pilot director system panel vertical speed. You can descend like this. You can see the minus, so you can climb. So we have a few things to set. You can see now new airspeed over here in the primary flight display. So we set APU. We need the APU to start the engines, the auxiliary power unit. Primary flight control computers in the auto position. We have the left and the right IDG, the great drive generator, left and right engine, 180 to 200 volts, 430 frequency. IRS data computer flight control surfaces over here. We have towing power, FD door over here, passenger oxygen over here, window heat, rammer turbine, left and right engine driving, hydraulic pumps. If we turn them off, and the electric, you can see what they display. So we turn them back on into the auto position. We have the wing and engine at the eyes over here, on or auto. For this flight, we have also air data recorders, cargo fire and APU fire, electronic engine control for the engine with the auto start system. Normal and alternate controls the FAREX, the full authorities electronic control computers. We can arm the switch to dump some fuel in flight and select how much to remain. Also we have the left and the right wing fuel tanks over here, fuel booster pumps, the crossfit valve. We turn it on, can feed other engine without a pump or the tank and balance the fuel between the left and the right wing tank. Also we have the cabin pressurization here. In the auto, we use the manual, we use the outflow valves for climb and descent, open and close, select the landing altitude. So we use the automatic. We have also the lighting system, windshield wipers, and also the bleeder from the left and the right engine. From the APU, we have the air conditioning, ventilation, and oxygen and cabin pressurization. Other things we need to know before going to the engine start process. We have the system display over here, so you can see what they display. The hydraulics, APUs running, oxygen, liquid cooling, the electric over here, left and right IDG, the great drive generator, APU, main battery, 120 to 200 volts, 400 Hz frequency, battery voltage 38 volts. So we have the hydraulics, where the hydraulic fluid goes, which system use it, demand primary C1 and C2. Also how much we have 5000 psi in the quantity of the hydraulic fluid. The fuel on board, we have 37 and 37, 145 total fuel, 290. You can change low and high pressure fuel valves, left and right engine, feed both engines. The APU is fed from the left wing is this motor. The crossfit can feed either engine with either pump or either tank, or balance the fuel between the left and the right wing. You can see also here we have the minimum fuel temperature, below which the fuel would freeze minus 37 degrees in flight, and the fuel temperature right now. So the FAREX, the full authority electronic control computers, control automatically the recirculation of the fuel from the wing tanks and the center tank to heat it up in flight using the circulation to the engine components. And also we do the same for the lubricant and the oil. So we have also the air pressurizer, oxygen. The doors are closed, the cabin to be pressurized, the gear is the temperature of the brakes and the pressure of the tires. Flight controls over here, flight control surfaces, climb and descent, the elevator, the rudder pedals, also for the door trim stabilizers. For the last thing to see before going for flight. FS display over here, maintenance over here, circuit breakers. So we have also the checklist, what we need to know, normal menu before start, after start, after takeoff, descent, approach, landing. So we go communications, navigation display also. We need to start the engines. So I'm gonna make an engine start demonstration right now. I'm gonna shut down the engines. So Both have fuel control. As you can see, fuel control to the off position, like this. So you can see it displays some warnings over here, some fusions with amber color. Also you can see the engines are running down right now. You can hear the sound of the engines of the Boeing 787. The hydraulics also we need to restart very quickly, both auto start in the auto position over here. You can see the reconfiguration. Now we have bleed air from the engine, from the APU actually, into the engines to start them up, to pressurize the engine starters. So above 20% we can initiate the fuel flow. We can see we have only pressurizer right now. So we initiate here the fuel control, both left and right fuel valve. It will take like 1 minute and we'll go for takeoff. We're gonna have the engines running. So you can see the auto start is kicking in. Auto start. So we have higher engine thrust now. So you can see the warnings are going off, and above 60% we can start the takeoff process. We're gonna have the running engines. So we can see both engines are running. So flaps for takeoff over here, and advanced parking brakes off, advanced the thrust levers. So we take the runway clearance from the air traffic control over here, and we taxi into the runway. The runway is open for us, as you can see. We use the tiller to taxi over here. So we need to align with the runway heading. So we advance the takeoff thrust over here, as you can see, full takeoff power. We have the yoke down and the rudder pedals for alignment. So we have 80 knots over here, aligned with the center line. We have only the rudder now, aerodynamically effective. So we have 100 knots, 120, 30, 40, 50, V1, V8 over here. So we pitch up slightly, like 9 degrees, and we have the takeoff rotation over here. So we are a little bit heavier right now. We have full takeoff weight in fuel. So it took us a little bit longer to climb, as you can see. So keep climbing, full takeoff power. You can see we have all the air data here as we keep climbing. So you can leave the hands off from the flight controls, no problem. So we keep climbing. We are 1,400 feet, 500 feet above the ground, as you can see. The stall speed over here. Also the heading, the terrain around us. We climb with about 1,500 feet per minute. Over here we can use a few more flaps to avoid the stall. We're gonna be stalling if we are pitching up too much the aircraft. you can see further away the terrain around you. So land gear up like this. So you can see we are just like a couple of thousand of feet above the ground over here as we're climbing. Full engine power right now, and we're gonna be climbing here off the airport. As you can see, the airport behind us, around also the Switzerland lake. So we start the turn over here. Have to make a more shallow turn. To avoid the stalling over here of the aircraft. So keep turning over here, as you can see. Heavier aircraft is also more difficult to climb over here, as you can see, and develop an airspeed. So it's better to have less flaps right now to increase the airspeed of the aircraft. So we almost near stall again. It's very heavy aircraft and more difficult to climb to the cruise level. Gonna take a few more minutes to climb to like 30,000 feet or so. So right now we are 7,000 feet only because we are very heavy, the aircraft in this flight. But it's no problem, we're gonna have to climb to lower altitude, that's all, as we fly. So hope you enjoy flying lower altitudes with us. I'm gonna climb maybe to 20,000 feet, and then we're gonna descend for approach landing. As you see, we are 8,000 right now, climbing. You can see the air data of the aircraft. We have full takeoff weight almost. So maybe we can dump some fuel to lose weight. So now we're dumping fuel to make it lower for landing. So gonna lose some weight like this from the fuel on board. We don't need to have as much fuel. So we make a turn now. Keep climbing, 10,000 feet, the airspeed 170 knots to align 35 nautical miles. The next waypoint over here. We pass the Zui waypoint, as you can see. So we select the systems. We can check over here the fuel. We have select to dump some fuel over here. It will take quite a time to jet all the fuel over here off, as you can see. So we set back the navigation display over here, and now we make a turn for going back to the airport. So we are 12,000 feet right now. You can see we are closer to the lake, the Switzerland over here, the France, the Germany. We have the Germany in front of us, my homeland. So we're gonna be flying slower and lower altitude because of higher weight, and we have 9 minutes to go back to the airport. So we start the turn. So make a turn over here, more shallow turn because we have higher weight. So we are flying here, as you can see. We have the Germany, my homeland, the Bayern Munich in this side, the France in the other side, the Swiss Alps. So I hope you like the lakes here. You like we're flying with the Boeing 787. You can see. I'm gonna start descent in a couple of minutes, maybe now. So we keep turning, as you can see. We need to follow the flight plan over here. Hope you like also the galactic view of the aircraft as we fly. The galaxy over here, the frozen vapors of the aircraft. So hope you like the frozen vapors like this. We have a few more minutes to go to the airport for landing. Also the lakes over here, as you can see, the Germany, my homeland, behind you with the lakes, the France also over here, the France, the Italy this side. So we're going back to the airport. We need to start the descent now. We are 14,000 feet, so this had an impact the fuel on board into the altitude we could reach. So we start the descent now. We have 6 more minutes to go for descent and landing. So we initiate over here the descent. You can see we can flying over here. We have a nice view also of the cockpit over here. So we start descending. Increase also the airspeed a little bit. So we're flying closer to the airport like this. We have 5 more minutes left. So we increase the airspeed now. Approach and landing. So we're gonna have an airspeed, maximum airspeed right now, Mach 0.6, as you can see, as we are approaching over here for landing. So decrease the thrust a little bit. So we have 4 more minutes left for going into the approach and landing over here, as you can see. So we keep flying under the aircraft. 9,000 feet. Idle thrust over here. So we need to start the turn now over here for approach and landing. So we're gonna make a nice turn. Hopefully we're gonna make it before the time of the video ends. We need to make this turn, align with the runway, heading over here. We're gonna add some thrust. So we are aligned over here with the runway. We need to be almost. So landing gear down. Also flaps, full flaps. I'm gonna use. So we pass through these clouds over here, and we are aligned for landing, as you can see. So we're gonna use also this view for the landing, as you can see over here. So we keep descending. Use a little bit left rudder now to align with the runway heading. Also use a little bit more thrust whenever we need. So you can see we have some side wind, some wind gust over here. We need to align with the runway heading. Also we have the Lszh localizer here. We follow the Lszh localizer whenever we need. Align with the runway heading. A bit thrust over here whenever is needed. So we almost reached the approach and landing over here. Align with the runway heading, side wind and wind gust. We use the rudder pedals. Use a little bit more idle thrust for the touchdown over here. So we're gonna be having the flare, as you can see, flare, beautiful flare over here, idle thrust. So touchdown, parking brakes, thrust reverse over here, reverse thrust and parking brakes. And we are slowing down the aircraft, as you can see.